And we're on. Hello, students. Welcome back for day 2 of learning our math and secondary math 1 honors with Mr. Singh. I being Mr. Singh. Just a couple things. Please make sure you're checking Canvas, looking at those announcements. I think those announcements are coming to you through email, but if not, make sure you're checking in Canvas. I usually try to post every week, and that's my plan, is to post every week and every other day probably. Okay, let's get into the lesson, all right? So 2 things you need today. You need a piece of paper. You need a calculator. I'm going to use my trusty Wabbit Emu. It's been pretty slow for me today, but I'll just keep using it. And let's get started. Today we got our do now. So looking at this comes back from the other lesson, right? We're talking about parallel and perpendicular lines. Remember, with parallel lines, we got to have the same slope, right? So that slope needs to match with the other line. And to get perpendicular, that's going to be our intersections, right? Like driving, we got an intersection. That's when you have 90-degree angles inside that cross. And also, when you think about the slopes, right? When you multiply them together, they equal -1, okay? So let's go ahead and get started with this. It looks like we got the same points and we have the same equation. Looking at A, we want to get a line that passes through 6 comma -2 and is parallel to y equals 1/3 x minus 8. And that will be the same thing with B, except the differences between those two is we need a parallel line and we need a perpendicular line, okay? Remember, the first thing we need for parallel line is we need to find that slope. With parallel lines, we say the slopes are the same, so I can find here that my slope is 1/3, okay? Then we have to use point slope form. Remember, point slope form is your y minus y1. If I have the point 6 comma 2, I have x1 is 6, and then y1 is -2, right? So then if I do that, I have y minus my y1, and that should be -2, equals my slope, which I found is 1/3, parentheses x minus 6, my x1, right? So now all I need to do is simplify that, and that's your equation, okay? If I was to do this first, I gotta do the left side. I see I have y plus 2, okay? Minus x plus. The right side, I have to distribute that, so you get 1/3x minus 1/3 times -6, right? 1/3 times -6, that gives us -2, okay? One last step is I got to subtract 2 to both of those sides. When I do that, I get y equals 1/3 x minus 4. Okay, let me reveal this little gray block over here, and that's our answer. There you go. Go ahead and try this next one. Okay, we're going to use the same point, but now I want a perpendicular line. Remember, perpendicular line, we need to have slopes that are 2 things. One of them is the opposite sign, and the second one is needs to be reciprocal. When it's reciprocal, the numerator and denominator, they switch sides, right? That's what's going to happen here. So if I was to get the slope of 1/3, I know that my slope for my perpendicular line is going to be negative, because that one's positive, and then the reciprocal of 1/3, which is just 3/1. That can be simplified into -3, and I'll just use that, okay? When I use point slope form again, I need to find that perpendicular line to y equals 1/3 x minus 8. So I'm going to say y minus y1. That's the same y1 as before, equals to -3 times x minus x1, which is 6, okay? So go ahead and simplify that. We get the same stuff going on here, right? Y plus 2. But distributing that, we get -3x minus 18, okay? Just double checking that. Oh, that's plus 18, okay? Make sure you double check your answers. And again, the last thing I gotta do is subtract 2 to both sides. So y equals -3x. It's kind of hard to write on this. Plus 16, right? Let's go ahead and double check with our answer, and that's what we got. There you go. That's what we learned before, right? Okay, today we are learning about distance formula. That's going to tie off our Pythagorean theorem that we learned before. Remember the a squared plus b squared equals c squared, okay? We'll look into that a little bit and start building on to this idea of distance formula, and then we'll be able to find perimeter and area, okay? That's what we're going to do. Use that equation. Okay, so if I have this scenario, I need to find the perimeter of this triangle. We need to do that by finding the lengths of side A, B, and C. Remember, the perimeter of anything, right? The perimeter of anything is the distance around it, right? So if I was to look at this right triangle, I just need to find the distance between A, distance of B, and distance of C, right? Well, looking here, that's a right triangle. So we are definitely going to use our a squared plus b squared equals c squared. Okay, that's our right triangle Pythagorean theorem, okay? Well, counting a, let me use green this time to kind of distinguish it. I can count this because it's on a graph, right? I can see that my distance of A is 4, my distance of B is 1, 2, 3, 4, 5, 6, 7. And I can say C, I'm not quite sure what C is, right? You can kind of count, you can kind of guesstimate in your head, but as far as I know, that's going to be a lot harder, and we need to use the Pythagorean theorem for that, right? That's why we use it to find C, or the hypotenuse, okay? So you have your A, which is 4 squared, your B is your 7 squared, and that's equal to what we're trying to find, all right? Simplify that, you get 16 plus 49, and that's equal to C squared. Okay, bring those together, we get 16 plus 49, that's 50, 65, right? So 65 is equal to C squared. Remember, the last thing I got to do is I need to square root both of those sides, okay? I'm going to just straight up use my calculator with this one. I'm going to turn it on. Keeps on turning off on me, I don't know why. Let's give it a second to kick. But again, I'm going to square root both of those sides, and I should have the square root of 65, okay? Square root of 65 is 8.06, so that's going to be 8.06, okay? I usually like to round things to the hundredths. From my experience with science, with math, we always just kind of accept the hundredths place, sometimes the thousands, okay? But that is my distance, class. My distance between my distance of side C is 8.06. I'm not quite done yet because I need to find the perimeter, right? If I know that C is equal to 8.06, my perimeter, let's just say perimeter of triangle, let's just call this ABC. Well, that's going to equal all those sides added up together. So 4 plus 7 plus 8.06. All right, class. We can simplify this together. We get 11 plus 8.06. So my perimeter now is going to be 19.06. Okay. Feel good about that? So we've used a lot of different ideas here, right? But just tying with geometry, we use perimeter and the Pythagorean theorem specifically and find those sides. Okay, let's try and make it a little bit harder, where I take away that triangle and just give you this side, this length, length of line segment, this segment CD, right? This segment CD. If I was to look at this, well, there's no numbers there, so that's kind of an issue. But if I'm trying to find that line, well, if you look at it, imagine it creating that right triangle, right? If I create that right triangle, I know that, oh, right triangle is always Pythagorean theorem. So a squared plus b squared equals c squared. Okay, class? All right, so go ahead and count one of our sides. Let's do the horizontal. I can see, let's say that's A, that's 3. And then let's count the other 1, 2, 3, 4. B is equal to 4. So I know that I have 3 squared plus 4 squared equals that C squared. I'm not sure about, okay? I don't know what C is. That's what my line segment CD is. That's what we need to find. But if I was to solve this, I can just simplify that. 9 plus 16 is C squared. Well, that's 25 is equal to C squared. Don't forget the square root, right? And what's the square root of 25? Well, that should be an easy one. That's just going to be 5, okay? So my square root of 25 is 5. So 5 equals C. And so I can say that CD, the line segment from C to D, is equal to 5. That's my answer. Feel good about that? It's only getting harder, right? That's what we do. Okay, let's go ahead and pull out the graph, and let's just leave you with 2 points. We got 1, 3 and 7, -2. I encourage you to pause the video, see if you can find that length yourself. Right off the bat, I can see that I have a right triangle, right? So I know instantly, oh, right triangle, Pythagorean theorem. I need to find some sides, right? Oh, which side am I trying to find? I'm trying to find R. R, ooh, that's a hypotenuse, right? Just continuing on though, so I know that I need to find R, but I need to know what A and B are. Well, because we have these 2 points and we know the position of them, right? It doesn't matter necessarily where on the graph it's going to be, or you can make up your own graph, whatever. But I do know, I see that I have 2 points here that has X and Y values, or horizontal lines or vertical lines together, right? So if you look at, let's just say, the vertical, I see that your y values are 3 and -2. Okay, well, think about this. How far away is -2 away from 3, right? We can think about the difference. We can think about the distance between those two. I can see it as, let's just make our life easier. Let's just say -2 minus 3. Okay, when we do that, that gives us the distance between those two, okay? This is going to give us a negative, but you'll see that won't necessarily matter in this problem. If I was to do it the other way, let's just say we did 3 minus 2, right? That's going to give us 5. Either one works. That's totally fine because you'll see with the Pythagorean theorem, it doesn't necessarily matter, okay? But if I look at the x values, okay, I'll do this in green. If I look at those x values, okay, between 1 and 7, you got to ask yourself, okay, well, how far away is between 1 and 7? I can see that as 6, or I can just do 7 minus 1, or 1 minus 7, right? That's going to be 6 or -6. Okay, well, let's just stick with -5 and +6 as our legs. Okay, and we'll see that that'll give us how we get R, right? You're probably seeing it now, but I got to teach this lesson and get through it. So we got A, that's -5, okay? Plus my B, well, B we said is +6. And then my C, we'll say that's R, okay? Notice how this is pretty straightforward. We just have to use our calculator, take that square root at the end, right? We square -5. What does that give us? Well, that gives us 25, +25. Notice how if I threw in 5 in there, I would still get +25. Reason why is because of squares, right? When you square two numbers, doesn't matter what they are. Usually square itself, you get negative times negative is a positive, and a positive times a positive is a positive as well, okay? You always get a positive answer if you square just that negative. Make sure you put parentheses in your calculator. If you don't do it, you're going to get it wrong, straight up, okay? Let's keep going. So now I got 25 plus 6 squared is 36, and that's equal to R squared, okay? We put those two together, we get what, 50, 61? I get 61 is equal to R squared. Last thing is square root. Well, what's the square root of 61? Okay, let me pull up this calculator again. There it is. I'll go second squared to get the square root of 61. That's going to give me 7.81, okay? So 7.81 is equal to R. That's my answer. Feeling lucky? Okay, what if I make this harder now? So I just give you 2 points. Okay, we got to think about this. I'm not going to solve this right away, but that's going to give us to our next point, which is our distance formula, okay? So if I have 1, 3, 7, -2, we need to get to this next part, which is our distance formula. Okay, we're going to build onto this. Again, if you understand that, that's great. You're more than welcome to skip ahead. I'm just going to try to help you develop why we get there, right? And hopefully I'm explaining it well. I'm doing my best, I promise. But you can always ask me questions in the comments or email me, right? Okay, so if I was to look at this, all right, I know the distance formula is going to be, says there, a numerical description of how far apart objects are, all right? What's nice is distance formula is used everywhere, right? It's used on your Google Maps. It's used with people who hike. It's used when you're using a map, right? It doesn't matter. We're using the distance formula. Granted, we're not going to be like calculating. We're not punching those numbers using our calculator, right? But I do understand that when you're using Google Maps, that's all just little lines all together, and it's using this distance formula, okay? But if I was to use this distance formula, we understand that we're using Pythagorean theorem, right? Or a squared plus b squared equals c squared. Notice how, let's say in our triangle right here, okay, that we're given a, b, c, and d. Let's say I know what point A, point C, and point B are, okay? And let's say I know the distance between A, or the distance of A and the distance of B, right, lowercase. But I don't know what distance C is, okay? That's where this kind of plays together. Again, kind of work with me here. I'm trying to figure this out myself if this is the first time going through it. But I know that I have my Pythagorean theorem, a squared plus b squared equals c squared, right? Well, let's say that if you look at that triangle, if you look at the blue points, okay, the x1, y1, x2, y2. Well, just like what we did before, if we're looking at that blue side, okay, we're only going horizontal, right? Well, how did I find the distance of that side right there? Do you remember? Okay, what I did was y2 minus y1, right? You're saying is how far away is y1 and y2 apart from each other, right? I can already count that if I wanted to right now, but that's what we're saying. Well, that's your A, okay? If you look at the red, the horizontal, that we can see that those are our x values, right? I found that again before was just x2 minus x1, right? It's the distance between x1 and x2. How far away are those 2 points from each other, right? So if I was to simplify this, well, I could say A is going to be x2 minus x1. Okay, don't get intimidated, all right? Again, the x2 minus x1 is your horizontal side, right? That's the B or the A side in this case. A little bit weird, but that's the horizontal side, right? And plus your vertical side, which is y2 minus y1 squared. Again, that's that leg that's going vertical. All I did was just take the distance between those two, okay? And that's equal to c squared. That's the side we're usually trying to find when we use this distance formula, okay? Okay, and that gives me, well, I have to square root everything. When I square root everything, I see that my c value, my side c is equal to the square root of x2 minus x1 squared plus parentheses y2 minus y1 squared, okay? I can simplify that and say for distance, we use the letter d. Our distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, okay? Looks like that's the same, but again, this is very huge when it comes to finding distance of things, right? Go ahead and write this down. Make sure you write this down. Make sure you feel good about it. And yeah, and we'll keep moving forward, okay? Can't think of anything else going on here. But for example, let's use this graph again. So I'm going to use that distance formula. Let's say now we know what our points are. Okay, it looks like point A is -6, 9. Point C, that bottom left where that right angle is, that's -6, 1. And point B is 7, 1, right? Well, all the distance formula is just going to be your y values of those 2 points vertically subtracted together, right? And then the x values of the horizontal points subtracted together, okay? If I was to do this, I'll do this step by step, I promise. We're trying to find that distance c. I can say that, I'll do this in black, c is equal to my square root of my x values. Notice how my x for c is -6 and there's 7, right? Let me double check some things. I don't want to get you messed up with it. But I'm going to say that this is my x1 and this is my x2 for the red, okay? It doesn't necessarily matter because, again, we talked about this, right? If it's a negative positive, it's going to get the same value, except, opposite signs. You square it, you're going to get a positive number. So I'll just, kind of guide you there. Let's just say we have x1 is -6 and x2 is 7. So that's going to be 7 minus -6 squared, or -6 parentheses squared. Okay, and that's plus our y values. Let's say, man, I don't want to mess you up too bad. Just trying to make sure. Let's say this is y1, and we can call this y2, okay? Doesn't necessarily matter, but we could say we have y2, which is 9, subtracting y1, which is 1 squared, okay? I'm just double checking. It's kind of hard to multitask when you're recording, doing all that, right? Okay, so I get c equals the square root of, I'm just going to keep simplifying this. I get 7 minus -6 plus 13 squared plus 9 minus 1 is 8. 8 squared. Keep on going with that, okay? I'm going to do this in black. So c equals square root of 13 squared, which is 169, I think. I always forget that one. So 13 squared, 169. plus 8 squared is 64, right? Add those up together. Plus 64. We get 233. So C is equal to the square root of 233. Or I can say the distance is going to be the square root of 233, which is 15.26. 15.26. Okay, that's my answer. That's the distance between A and B. Okay, do you see that? That's that C distance. Okay, do you feel good about that? I think you do. Again, you're more than welcome to review this again, right? Go backwards. Or you can ask questions. Do what you can to learn this, okay? All right. So if I was to find this one again, okay? I got 2 points here. I need to find the distance between those two. Well, this goes back to, let's just label them, okay? Let's say that 2, 4 is your x1, y1, and 8 minus 1 is going to be your x2, y2. Okay? Again, you're more than welcome to pause this, write this out. Make sure you process this, okay? And then now I have my distance is equal to my square root of my x2, which is 8, minus 2 squared, plus my y2 minus my y1 squared. That's equal to the square root of 6 squared plus negative 5 squared, right? That's my distance. Keep on going. I get 36 plus 25. I'm just going to double check my calculator just so I can be precise with that. So I got 25 plus 36. That's 61. I think I saw this number before, didn't we? So my distance is equal to the square root of 61, or I can say, I don't have a good memory of what it was. It was like, what, 8 point something? 7.81. 7.81. Okay, that's my distance. Okay. Hopefully you feel good about that. Again, if I show you the steps again, that's what we did. I'll leave this slide up as well. Don't worry about that. Okay, now it's your turn. Go ahead and pause this video, see if you can do it yourself, and double check your answers with me, right? Ready, go. Did you pause? Hopefully you did. Okay, well, I didn't write this out. I just have the answer right there, right? Where I have, again, you have your x1. Let me just clarify all this, right? Your x1 is -5, and your y1 is 1, and your x2 is 2, and your 7 is your y2. All right, there you have it. Okay, so let's just try this again, just so we can feel comfortable with it, right? And then looks like the next two you can do on your own. You're more than welcome to kind of just go forward with this if you want me just jabbering and just see what I did overall, right? But let's look at this. So my distance, I need to find the line segment of R. I have those 2 points. Let me label them. I got x1, y1, x2, y2. Okay, well, my distance is equal to the square root of my y2, or no, my parentheses, x2, which is 7, minus x1, plus y2 minus 3. Square that as well. Okay. Trying to be careful, right? I got 6 squared plus negative 25 squared. Whoa, see, this is what I'm talking about. Negative 5 squared. Doing that thing where I'm jumping ahead. Simplify that. You get square root of 36 plus 25. Okay. That turns into the square root of, what is it, 61? Is that really the same? So my distance is equal to the square root of 61, which I know is 7.81. I didn't see that coming. We're going to say about these squiggles, right? You see those squiggles? That means about, mostly because we have this long irrational decimal, right? But that's good enough. So my distance is equal to 7.81 about, or I can say R is about equal to 7.81. Okay, that's more precise. Okay. All right, you try it. Go ahead and pause this video. I have to write this one out now. Or I can use the movie magic. Let's see if I can do some movie magic. Wait for it. All right, we're coming back to him. Boom, there's your answer. Yeah, so I just picked my 2 points, x1, y1, x2, y2, and then I just put it into my formula, or I know that's related to the Pythagorean theorem, and I just need to find the distance between them, right? Okay, here's another one. Pause that video. Did you pause it? I don't think you did. I know who you are. Just kidding. Okay, let's look at this again. I'll just do this one. That took a while when I did that movie magic. Okay, so your x1, y1, I have 1, 5. Your x2, y2 is 5, 8. My distance is going to be the square root of your distance between your x's plus the distance between your y's. Well, that goes to 4 squared plus 3 squared. Oh, this is going to be easy. I already see it. 16 plus 9, 25. Square root of 25, well, that's going to give you 5, okay? There you have it. Okay, good work, class. I think that's pretty much it for the lesson. So again, what you learned today is you use the distance form to solve equations. We're going to keep on using this to help us find perimeter and eventually area. Just some other things to keep in mind. Please don't forget to comment in the discussion. You need to do that to get credit for the day. What's something to work on? There is a learning activity that is found on Canvas. And again, with retakes, you're more than welcome to sign up. Since today will probably be Thursday, I believe is day 2, you can only sign up for the Friday one, and I'll send another form that you can fill out, okay? Another thing is, feel free to come to my stream. I'm streaming at those particular times. I'm going to try to use YouTube live stream. Should be a fun time. But other than that, I hope this was a good lesson for you. Again, I am doing my best. We're just all working together trying to get better, right? But just keep on being awesome. Keep working hard. You know what to do, right? And I'm here for you, right? Just email me. Send me a email through Canvas or my personal email. And yeah, that's pretty much it. Good job.